Hello, everyone. My name is Anika Taylor. I am the Outreach Programs Manager at the Bakken Museum, and I've spent a number of years working with students in various different education environments, all about STEM education and STEM engagement. So over this time, I've made some discoveries and worked with some really interesting people about designing activities that really engage the audience in what you're doing, as well as allow you to evaluate a little bit the success of those activities in teaching actual content, topics, or points to your audience. So the question that this started off with is the idea that we have all seen many classic science demonstrations in our time. It's one of the sort of standard practices for how people like to teach science topics, is they show off something very cool and then explain why that happened. But some colleagues of mine began to wonder, does it actually work? Do you actually teach people these topics, or do they just walk away kind of remembering that something cool happened and not really understand the ins and outs of it? So a number of years ago, some folks, we'll start off by actually showing you, my mistake, we'll show off by showing you an example of a classic science demonstration. So this is one we like to call Will It Light? All right, so ladies and gentlemen, I have here a device. We call this a conductivity tester, and I have here a light bulb. We have it connected to some power in the wall, and what we need to do in order to get our light bulb to light up is to complete our circuit. And in order to do that, we're going to have to connect this yellow piece to this yellow piece. Now, we could probably search around the room and try to find some different things that might work for that, but what I also happen to have here are a bunch of jars of liquid. And we're going to see which of these liquids we can actually get electricity to move through to get from this yellow piece to this yellow piece and make our light bulb light up. So the one I want us to try actually is just plain old pure water. So ladies and gentlemen, we are going to find out, does our water light up our light bulb? Can I have a little drum roll, please? Fantastic, and oh, it does not light up. Now, that might be a little confusing for you folks, but the reason why our light bulb doesn't light up is pure water doesn't have any charged particles in it. And electricity is actually just the movement of charges. So if we don't have charged particles in our water, we don't have any charges to move, we don't have any electricity that can move through that space, and our light bulb doesn't light up. So, we've now seen this demonstration, and this brings up the question. So, does this demonstration, do any science demonstrations actually teach people content or actually teach them information? And it turns out that no, they don't really. People might remember something interesting, they might remember something fun, but on the whole, people aren't actually getting the concepts that you're trying to impart beyond just the sort of wow factor that something happened. Now, if we add to them a little bit, we can actually grow these science demonstrations and give them a little bit more clout in order to let that topic sink in a little bit. So one of the ways we came to understand that these demonstrations don't really teach is there was actually a study done a number of years ago where they had a bunch of teachers provide these science demonstrations to their classes, and then they assessed 2 weeks later what people actually remembered from that experience and what information they actually took from them. And they discovered that in this time, only about 25% of these students actually remembered the concepts accurately. Only 25% walked away from those demonstrations actually remembering the point that they were trying to make. Another 16% weren't totally sure about what was going on. They maybe remembered bits and pieces, but weren't able to fully deliver the idea back. And this is the crazy one. 59% remembered these concepts directly inaccurately. In many cases, these were the preconceived concepts they had coming in. They saw the demonstration, and even if it would indicate something else, they still remembered it the way they thought it was before. Or in other cases, they sometimes even remembered what happened in the demonstration itself inaccurately, much less the content surrounding it. So 59% were actually getting it wrong, which is pretty crazy.